Greetings, guys. Last time we talked about three trig ratios, right? We talked about the sine of an angle and how that the sine of an angle is equal to the length of the opposite leg over the hypotenuse. And we talked about the cosine of an angle. We talked about how that is the length of the adjacent leg over the hypotenuse. And we talked about the tangent of an angle, where the tangent of the angle is the opposite leg over the adjacent leg. And we talked about how we find missing sides of right triangles with that. Okay, the biggest problem I'm seeing is when y'all have a triangle, just simply identifying this. Once you've identified opposite, adjacent, hypotenuse, you're doing pretty good at setting them up. So identify an angle first. And the angle is usually going to be given to you. Well, it was last time. Today it's not. But I'll show you what we're talking about. So if I have that angle, look at the hypotenuse first. The hypotenuse is the longest side. It's also across from that 90-degree angle. So if I go across the 90, there's 90 right across from it. That's the hypotenuse. Get that in place first. And guys, until you can memorize it very fast in your head, I would just write it down, make a note. This is the hypotenuse. Then opposite. The angle is across from the opposite side. You're never going to be talking about an opposite angle or an adjacent angle. It's always an opposite side. So there's my angle. Opposites over here now. Okay? And that means this is the adjacent. Now, if that was not the angle I'm interested in, so for example, if I was interested in this angle over here, okay? And let's say I don't even know, but that's the angle I'm interested in. This is no longer across from that angle, so it's no longer opposite. So it's no longer adjacent. This is now the opposite side, and this is the adjacent. Hypotenuse will stay the hypotenuse, okay? Now, what we're going to look at today is how do we use our trigonometric functions to find missing angles. So let me show you. I want to do one example and then one practice problem with you for what you're going to do today, and then I want to give you some instructions. So let me scoot that up. Suppose I have a triangle like this one. And let's suppose this is 55 degrees. Oh, I don't want to do that. That's X. I want to figure out what that angle is. And I know that this side is, this is 25. And this is 35. Okay? So I get out my thinking cap for a moment. I say, okay, my angle. There's the angle that I'm going to deal with, and it's because I want to know that angle. So this is the hypotenuse because it's across from the 90. Okay, so hypotenuse. This is the opposite. So I know the opposite. I know the hypotenuse. Opposite and hypotenuse. That leads me to the sine trig ratio. And so I set up my equation. The sine of an angle is equal to the opposite over the hypotenuse. And I fill in the blank. Sine of X, because that's the angle I'm missing, equals the opposite, that's 25, over the hypotenuse, 35. Okay, so I don't take a cross product here because what I want to know is inside the sine. So I need to find something that undoes the sine. Okay, now, when in the past years, we've learned about addition and subtraction. Addition undoes subtraction. We've learned about multiplication and division. Multiplication undoes division. Addition undoes subtraction and vice versa. We've looked at a square root that undoes a power of 2. A cubed root undoes a power of 3, and so forth. Okay? All of these are operations, and what's over here is called their inverse operation. The inverse of a sine, or what undoes a sine, is called an arc sine or an inverse sine. You'll hear them called both. It's this sign with this little -1. And I forgot to get a calculator, so hold on. I need to walk out. If you don't have a calculator right now, get one out. It needs to be a good scientific calculator. So get a calculator. Make sure that it's set in degree mode. Because if it's not, I've worked with 2 students in the past day that they got all their answers wrong because they were not in degrees in their calculator. Okay. So there's my calculator. You'll see, whoa, somebody's done something weird in my calculator. I need to make sure I'm in degrees. To do that, remember, up in the top of your calculator, you'll see a little teeny D right there. If it's not a D, if it's an R or a G, shift setup in my calculators, degrees right there. Now, I need to find the inverse sine. So here, let me keep going with this. The sine cancels the inverse sine because they undo each other. And so I get x equals the inverse sine. Now, let me back up. I need to get rid of the sine, so I take the inverse sine. If this was a cosine, I would take the inverse cosine. It's a cosine with a -1. If this is a tangent, I take the inverse tangent. That's tangent with a little -1. And I have to do it on both sides, just like we do in solving every other equation we've ever dealt with. And so I end up with x equals the inverse sine of 25 over 35. Okay? That's a calculator thing. This is a number. You just don't know it. Your calculator has it stored in it. I just got to find it. To do that, you see your sine, cosine. Oh, there it is. You see your sine, cosine, and tangent buttons. Above them, you'll see a little sine -1, cosine -1, tangent -1. To get those, see how they're gold or yellowish or whatever you think about? That means they're a secondary function, a shift function. So I've got to go shift sine, and then I can go 25 over 35. Right? Yep, that's what I have written. And I get equals, and I go 45 point, and you know what? I just want you to go to the nearest degree. Okay, 45.5846, so 46 degrees. Okay, I'll let you round to the nearest degree today. Okay, now, that's how we do it. We set up our trig ratio equations, and then we take the inverse equation. Now, here's what I'd like you to do. You should have already, if you followed the instructions on the board, grabbed the doghouse. If you didn't, it's up on the front desk. Go grab it now. I'll give you about 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. The doghouse. Now, when one of the things I love to do in my spare time is I like to build things, and not just random things, but things that I'm going to use in my yard. I mean, over the weekend, I built some compost bins. I built sheds. I've framed in lots of basements. I've framed up most of a house. I've built some furniture. I do a lot of working with wood, but I do some things with metal. But anyway, if I was going to make a doghouse, first thing I would do is I'd write out a plan of what's it going to look like. And I would map out all my pieces. And this is especially true if I'm going to do more than one, or I think I might make it again. And I would make what's called a cut list. I would make a diagram of all the parts that I need to cut and what the angles and measurements are there. So if I was going to make a doghouse, and it's going to be 48 inches by 24 on this end, and then I have these couple of rafters that pieces of a rafter I'm going to pick out. See, these aren't just 90-degree angles like I'm going to buy at the lumber yard or the store. These are cut to a specific angle. And I know how long I want it. I want a 30-degree angle. I want a 30-degree there. But I need to figure out that angle and that angle and that angle. Okay? And I need to figure out this angle so I can cut this board here, this triangle here. So my best advice, when you're looking at something like this, start figuring things out. And I mean anything and everything. And I start making triangles. So I'm looking at this. This is 24. That means this is 24. This is 48. That means that's 48 there. That's 30. So this is 30. I'm looking. Oh, you know, if I drop this right down there, that will make a right angle. And see, now I've got a right triangle. See it? Boo, boo, boo. Now, there's something else I know. I know this angle here is the same as that angle. And I know that that angle is the same as that angle. I know that because this line is parallel to that line, because that represents the sides of a board. And check this out. Here I have a big right triangle. If this is 48 from here all the way over, then from here to here is going to be half of that. That's 24. And this is 24. Well, now I know this triangle right here. See it? And I like to use color and highlighters. So I'm looking at this triangle right there. And I want to find this angle right there. Well, this is the 90 degrees is right there. So this is the hypotenuse. And this is right next to that angle. So this is the adjacent and hypotenuse. They lead me to the cosine. So I already did a lot of thinking and just kind of scratched out what are different measurements of that angle. There's always more to find than exactly the thing you want to find. Find everything. That way it leads you, that way your mind will lead you where you are going. Okay? So I have adjacent hypotenuse. Cosine of this angle, I'll call it R because it's the same as that. Cosine is equal to the adjacent, 24 over, oh, I forgot something, didn't I? My equal sign, dang it. Cosine of angle R equals the adjacent, which is the 24, over the hypotenuse, which is 30. Okay, now I'm ready to solve this. And I solve it by getting rid of the cosine, which means I'm going to take the inverse cosine of each side. That will cancel that. And so I get R is equal to the inverse cosine of 24 over 30. Now it's a calculator thing, right? So I'm going to come into my calculator and I'm going to go inverse cosine 24 over 30. And I end up getting 36.86. So I said nearest degree 37. And I said nearest degrees because when I'm working, I don't know that I even have a tool that I could effectively measure a decimal degree. And I don't know that I have applications I've dealt with very much that I have to. I know that they do. The tech college, they have very, very precise instruments and very, very precise applications. So depending on the application, you might want to get more precise. But I'm okay with just a degree. So we'll leave it right there. So that's 37 degrees. Okay. So angle R equals 37 degrees, or the measure of angle R. Let's figure out what else I know. Well, I've got 37 and 90. I could figure that out. Hey, and this is the same as this. These two are the same, right? So if I go 180 minus the 90 right there and minus the 37 from right there, that will give me this angle because this, and this, since they're in the same triangle, will add up to 180. So I'm going to go 180 minus the 90 minus the 37 gives me 53. So this is 53, which means Q is 53. So the measure of angle Q is 53 degrees. And I'll put boxes around these. Okay, now, so that's 53. I know this is 37 because it's the same as this over here. 53, I know this 90. P. Well, notice that P and this 37, they're separated by this one line. So they're angles, they're two angles made by the same line. That means they're going to add up to 180. So if I take 180 minus 37, 180 minus 37, I can't do that in my head right now. It's just been that kind of a day. As 143 degrees. That makes 143 degrees. So that means P is 143 degrees. So measure of angle P is 143 degrees. So if I had my cut list, I would make a panel and it's 24 by 48. That might be it. I like to draw little pictures on my cut list, and then I'd say, you know what, I need 2 boards like that, and they need a 37-degree angle right there, and they need a 53-degree angle up there. Oh, and it has to be 30 inches right there. So I know a length of one side, and I know these 2 angles. And I'm going to have 1, 2, but there's going to be 2 more on the other side. So I might say I'm going to need 4 of these. I'm going to need 2 of these because 1 on each end. So I make a cut list with all these different little diagrams like this. That way I can pull out my saws and my tools, and I can just start going to town, and I'll cut all the pieces, get them all organized, and then I'll put it together. Some people might do it one at a time. That's not what I do. But somewhere along the line, everybody I know that does a lot of work with things like this makes themselves a cut list. Okay, guys, your task is this. You got the doghouse. Pick 3 other pieces from the front desks. There are 6 to choose from. You've already done the doghouse, so you need this one and 3 others. And find all of the missing angles in those 3 pieces. And then you'll see on canvas, there's a place for you to turn it in. Okay? This is called the finding missing angles in furniture. Okay? And I shall see you guys next time. Bye now.